Hello everyone, and welcome to another Leetcode video. Today we're looking at the problem maximize the total height of unique towers, which was question 2 in Biweekly contest 140. So this question reads that we're given an array maximum height, where maximum height I denotes the maximum height of the ith tower that can be assigned. The task is to assign a height to each tower and meet the following conditions. So the height of the ith tower is a positive integer, this is important, and does not exceed maximum height I. And also, no two towers can have the same height. So we want to return the maximum possible total sum of the tower heights that we can assign, and if it's impossible to assign towers, you can return -1. So looking at the example 2, 3, 4, 3, we can see our output is 10. And why is it 10? Because we can assign the heights in the following way. So the first tower will have height of 1, the second will have height of 2, the third will have height of 4, and the fourth will have a height of 3. And you can see that none of these are the same, and all of these towers are less than the maximum height that we're given. So let's take a closer look at this example and see how we can solve it. So one way that you might think to do this is just to start at the front. So let's say we're looking at 2. Well, what we could say is, okay, well, we have 2. We know that the maximum height we can assign here is 2. Maybe we can have some sort of set or something that keeps track of elements that we've seen. We can check if 2 is in here, then we can add 2 into our set and say, okay, well, we haven't seen 2. Let's use 2 here and then move on. So we'll go to 3. We see 3 here. Well, okay, we haven't seen a 3, so we can assign a 3 here, put it in our set, and so on and so forth. So we do the same thing for 4, we add a 4 here, and then we get to 3. And this is where things get a bit more interesting. So we might say, okay, well, can we use a 3, right? That would be the ideal scenario, but we can't because we've already seen a 3. So, okay, let's maybe try the next greatest value. We can use 2. Well, no, we actually can't use 2 because we've already used a 2 before, right? So let's try the next greatest value. So we can go to 1. So then after all that, we eventually see, okay, 1 hasn't been used, so we could use a 1 here. So technically this will work, but the problem is that it's just too slow. The maximum height here can be 10 to the 9, right? And potentially in the worst case, for each n here, we might have to go through 10 to the 9 values, right? So we would do n times 10 to the 9, and this is going to be way too slow. And why is it 10 to the 9? Because we basically have to say we're at some very large value like this, but we've used everything from here until 1, right? So we'd really have to go and check all these values, see which is the greatest we haven't used, and then, try to find that value, and it's just very slow. So how can we do this in a more efficient way? So one thing we can do is that we can sort this array. So let's sort it. So we have 2, 3, 3, and 4. And how does this actually help us? Well, now instead of starting from the front, we can start from the back. And why do we start from the back? Well, we start from the back because we know we want to maximize our score, right? And if we start with the highest value, then we can assign the highest value possible, and it also makes it easier to track what we've already used. And how do we do this? So let's keep track of the max value we've used so far. And in this case, we'll say it's infinity, right? So let's come here. We're at this 4, so we'll check our max value that we've used. It's infinity. And this is going to be less than this, so we know, okay, we can use this. So we choose 4. And why do we choose 4 and not 5 or 3? Well, we don't choose 5 because, remember, this is the maximum height that we can have. So we can't do anything greater. And we wouldn't choose 3 because we can use 4, right? So why would we use a lesser number if we can use one that's greater? So here, what we're doing is we're saying the maximum we could do in this spot is 4. Let's compare it to the maximum value we've seen before. And if it's lower, that means we haven't used this value and we can use it. So what do we do now? Well, now we have to update our max value. So our new max value is 4. So let's move on. Now we'll go to 3. So when we're at 3, what do we do here? Well, we see take this 3 and compare it to our max value. So we see that the max value that we've used so far is 4, right? And this means that we may have used 4 and values above 4, but anything under 4 we have not yet used, right? So what does that mean? That means that we can use 3. So we could put 3 here, and we do 3 because it's the maximum we have here, and it's also less than this 4. But now we've used 3, right? So that means we can't use 3 again. So what do? We update our max value here. So now we come to this 3, and this is where it gets interesting. So now what we do is we come here and we see, okay, so our maximum value is 3. And this means we can't use this 3 again. And why is that? Well, we know that we can have any value up to 3 here because that's our maximum, but you'll see that we've already used 3. So what to do in this case? Well, we could do 3 minus 1, right? Because we've used 3, so we know that the value 1 less will be available because we've used everything from 3 and above, but everything below 3 is still fair game. So here we could put 2. Okay, so now our max value becomes 2 and move on to here. This is the same situation. We've seen the max we've used so far is 2, and this 2 is equal to this. So what can we do? We can do 2 minus 1, which is 1. So now we found that we have 1, 2, 3, and 4, which is our correct answer, but the benefit here is that we don't have to go through all 10 to the 9 values, right? We could choose a value in constant time because we're keeping track of it with our max value. So we don't have to go through this entire range from 10 to the 9 to 1 to find the next greatest value. We'll have it in constant time by just looking at our max value and making a decision there. So what's our time complexity? So to sort, we have to take O of n to the log n time, right? So this is what it takes to sort. And then after this is just an O of n algorithm. So we're going through O of n elements in this array. However, we usually use the largest element when we're doing big O complexity analysis. So we can get rid of this O of n and just consider our overall time complexity to be O of n log n. So let's take a closer look at the code and see exactly how we could solve this. So the first thing we're going to do here is we're going to sort our maximum height array. It's going to be in ascending order, so the smallest value at the front and the largest at the end. Then we just have 2 variables to keep track of. So max sum is going to be our answer. This is what we're going to return at the end. And then our max value represents the largest value that we've used so far. Then we're going to iterate through the array in reverse order. And remember, we do this so we can deal with the largest elements first and try to maximize the sum. So in this case, if our height is less than or equal to the maximum value, then what we can do is we can use that maximum height. So we know that the maximum height in this position is less than whatever max we've seen before, so we can use this value. But then we update our max value with this value here, the maximum height, minus 1. And this represents the next largest value that we can use for our next iteration. Another case we're going to is if our max value is ever 0. In this case, it means that we cannot place any more that are positive. Remember, all of the towers we place have to have positive heights. So if we ever get to max value of 0, we return -1. Otherwise, this is the case where we've actually used the element before, right? So in this case, what we have to do is we have to just add whatever that max value is to our sum and then decrement that value by 1 to represent that the next greatest value is the next one that we can use. Then at the end, we just return our maximum sum. So let's submit this and make sure that it works. And it does work. So hopefully this was helpful and made sense. If you liked the video, please like and subscribe, and thank you for watching.